This is a brief video describing measures of omission and commission, or the metric of false negatives, omission, and false positives, commission, and how we interpret these when looking at GARP modeling experiment outputs and how they relate to the best subset procedure. If you're interested in the best subset procedure, please check out our other video here on our Seer Lab YouTube channel, and that video is identified in the link below. I also want to point out this is a presentation co-developed with my longtime research collaborator Christina McNeesett out in Oregon. So let's talk about model error and the two types of error that we identify and describe when doing ecological niche modeling with GARP. We have omission and we have commission. Omission is also defined in the literature as false negatives. And a false negative means that our model does not predict the pixel where an actual point was recorded. In the case of a GARP model, that means a point where the species was actually recorded or collected was not predicted by the models. That's what we call the false negative rate. We've left out real data. Commission, on the other hand, is what we call a false positive, or the model predicts a pixel and we don't have a record of the species at that pixel. Now, in the realm of modeling geography or predicting geographic distributions, omission is an important model error because we know the model has failed to predict actual data. Commission, on the other hand, is a little more difficult to interpret because we're trying to predict pixels where we don't know that the species has been recorded. So generally, omission is what we consider a hard or a true error because real data have been left out. We could also have some other issues where the identification of the taxon that we're predicting could have been wrong. Species could have been misidentified at a location. Or what might often happen with ecological niche modeling is that we're pulling our data from multiple sources to derive a single data set of point events, and the location that was georeferenced may be incorrect. So those are two things that we would have to sort out as modelers before we ran our experiment. Or if we found that our omission rate was a lot higher than we anticipated, go back and reevaluate those data. The other thing that may happen, building on ecological niche theory, is that we may have records representing individual events or species identification outside of the niche that that species occupies. In other words, that location may be a sink or an area where the species was recorded, but it's an area where the habitat doesn't actually promote persistence of the species, what we would call a source. So if we have sink populations, that may also affect our omission records. And if we have species that migrate or move frequently or are pushed out of their environment frequently by either human activities or other species, that may also throw off locations of records. So those would all have to be evaluated. But what's important to keep in mind here is that omission is considered a hard error because we're leaving out real points, or we're failing to predict real points that have been recorded previously. Commission, on the other hand, is a little bit trickier. Commission, by definition, is the percent of the landscape, or the proportion of the landscape predicted positive. Okay? So it's the prediction, or the proportion of the landscape predicted by the model. So it's the percentage of pixels with a value of 1 present versus 0 absent. Commission by itself may result in overprediction. We may predict too much of the landscape, but that might not be an error. It may be that the species is found there and we haven't yet sampled it. It may also be that the environment is appropriate for the species, but it's not there because it's been extirpated, either by human activities or competition with other species, or it may not yet have moved into that area, what we would define as the fundamental niche in classic ecological niche theory. So predictions in areas where a species does not have a confirmed record can be caused by several things. As I've just said, the area could be suitable for the species, but sampling hasn't been done. The species may be there and we just haven't seen it yet or recorded it. Or that extirpation or local extinction or removal of animals from barriers, dispersal capabilities, etc., might all lead to overprediction or just predicting pixels. The third, which would be the truest, quote-unquote, truest situation, is that the area may frankly be unsuitable and we're still predicting it. That would make a true commission error, but deciding between which of these three realities is happening on the ground is going to take some interpretation. So because of that, commission is not seen as a hard error like omission is. So a couple of things to keep in mind. First, the selection of best models is based on a relationship between low omission and some value of commission that best represents what the species distribution most likely is. Keep in mind also that GARP is, by its very name and definition, a genetic algorithm. And that can be considered a random walk through variable space, meaning that GARP is going to build a series of rules and try and estimate which rules predict presence and absence and where those fall in the landscape. Don't forget you can learn more about that process in some of our other Seer Lab YouTube videos. Because of that opportunity for stochasticity, or randomness because of all those models, a single GARP experiment is made up of hundreds of models. The best subset procedure then reduces that down to the most appropriate models in an experiment, and those are what we then map. And you can learn more about that on our other videos here on the channel. So what we're looking at on screen here is the measure of omission here on the y-axis. So model that doesn't leave out any of those actual points would be here on the low end, and then here on the high end would be a model with very high omission or a model that's not predicting real data. So we know that those models would be inappropriate. And then over on the across the x-axis we have commission. And we know that if we predict 100% of the landscape, that model is not sensitive enough for predicting the species because we've predicted it everywhere. On the other end, if we predict a very low amount of the landscape, that's also not a good model because we're probably under-predicting. So we've got to find some balance here. And just to be clear, this set of points here are representative of the omission value and commission value of each individual model in a single GARP experiment. So a single experiment runs multiple models. Keep that in mind. You don't run a GARP model, you run a GARP experiment full of models. So using the work of several previous authors such as Soberon and then Anderson and others that described the best subset procedure, let's take a look at this curve a little more closely and how it relates back to predicting points on the landscape. So the area identified by yellow dots would be our occurrence points. Those are data on the landscape. And the area in green inside of each blue box is the area predicted by that given model. So here we have 4 examples where we have some estimate of the distribution. Okay, these areas that I'm coloring here. And we have some point distribution. So we have three scenarios identified here based on this same point distribution. Okay, we see it in each of these three scenarios. And we're looking at how each of those models predicted. So this blue box in each case would represent the landscape of this study. Okay? So let's look at each of these scenarios, looking again at omission plotted against commission, like we saw in the previous slide. So in this top example here, we have very high omission, approximating or approaching 100%. And so you can see here, our model has done a very poor job of predicting our testing data, and it's left out more data than it's predicted. So we have a very high omission, we have a very low commission. And these don't make good models. Let's look at our next example here. So we have very low omission, zero omission. That's ideal for omission, but our commission is essentially equal to just the individual pixels that we have where our points have occurred. So we have very low commission, and this is what we would call an overfit model, or we're overfitting the covariates to our point data. So this is also not a good model. And then we have our third scenario occurring here on the far side of the x-axis. We have a very high commission and a very low omission. So again, low omission is good. The model's predicting our testing data. However, if we have very high commission and we just predict the majority of the landscape, then we're not doing a very good job of differentiating the parts of the landscape where the species could be found and the parts of the landscape where the species could not. So we need to identify some kind of a balance between overfitting and overpredicting. So we have overprediction here on the high end of commission, and we have overfitting here, where we have low omission and low commission. And where we have very high omission and we can't even predict our testing data, then we're underpredicting. So we now want to find a balance between these scenarios. The ideal model is somewhere between here. So models with high omission error are definitely bad. Part of the reason we can say they're definitely bad is because, remember, omission is a hard error or a true error. Okay? Real data points are not predicted by the model. So when we start to build best subsets or try and identify out of that collection of models in the experiment which models we want to keep and identify as our best models, omission is going to be the first place to start. Because we know if we're failing to predict actual point data, we have a poor model. Commission, again, we don't know what the ideal commission value should be. That's going to be dependent on whether it's a cosmopolitan species that's widely distributed or a species with a very narrow geographic distribution. And because we won't know that ahead of time, we'll have to come up with a criteria for selecting the best commission values. So, based on extensive experimentation in the early days of building ecological niche modeling tools such as GARP, Anderson and others defined a best subset procedure where an omission criterion would be used to get rid of those models we talked about a moment ago, high omission leaving out real data. And then we've got to find the balance between the overfit models and the overpredicting models. So the way this works in the best subset procedure is to first set a rule about omission, to set a cutoff. Anything above that threshold is a model that's going to be excluded. The next order of business is to then identify the median value of commission for those models that are remaining below that omission rule. And then we'll select some proportion of those models to be our best subset. So after extensive experimentation, it was agreed upon that the median value would be the closest to the ideal commission for a good model. The process for defining or selecting models that meet these omission and commission criteria is already available and implemented in the desktop GARP modeling environment. When you run an experiment in desktop GARP, you have the opportunity to turn on the best subset procedures to activate it, and then to populate that with parameters, and those are described in another video on this same SEER Lab YouTube channel. So please check that out, and please relate what you learned in that video to what you learned in this video about what those measures of omission and commission are. In future videos, we'll discuss the area under the curve, another accuracy metric used to evaluate whether or not your models are doing a job better than random at predicting the landscape. So omission and commission can be calculated inside of desktop GARP, and desktop GARP can make a selection of the best models in an experiment. In this example on screen, this experiment is going to run 100 models, and it's going to arrive at 10 models in the best subset. And again, you can learn more about that on another channel. So let's have a brief summary of what's in this talk. In this video, we've learned about the two types of error that we define in the GARP desktop GARP modeling process. The first is omission, or a false negative. Okay, we fail to predict true occurrence points. So we fail to predict actual data about where the species we're trying to model has been recorded. Since those are actual locations, we can call this a hard error. So if we're leaving out actual data and we're confident that those locations are accurate and that the species was truly recorded there and not some sister species, then we can consider that a hard error. Our second error that we talked about is commission. And remember, commission is directly the percentage of the landscape predicted present. Okay, remember GARP is a presence-absence modeling approach. So it predicts only values of 1 for present or 0 for absent. When you watch the best subset videos, you'll see how these are multiple models are added up to produce a map of habitat suitability or potential species distribution. Okay, so it's the percentage of the landscape predicted present. Now keep in mind that we don't know the distribution of the species. That's why we're running the niche models. So how much of the landscape should we predict? We don't know. So commission is a soft error or not a hard error. We don't know what the ideal commission should be. So what was decided by Anderson and others, the 2003 paper, which is provided in a link below, above the comments. In this paper, it was decided that omission rules would set a cutoff for removing models with high omission, and that ideal commission would be the models that fall under that cutoff. It would be the models closest to the median commission value of the models that fall under that omission cutoff. And again, that's described in detail in some of the other videos. But as a reminder, commission is going to be difficult to decide what's ideal, so we're just going to use this rule of selecting the median values. And that'll create the best subset. Okay, so hopefully that informs you a bit on what the omission and commission, or false negative and false positive rates are related to GARP models. And as usual, you can drop me an email if you have questions, or you can leave a comment below and we'll try and address those questions for you. Good luck and happy GARPing.